Building Reliable Process Models, Part 3, Introduction to BPMN 2.0 Shapes. Today it's Gateways, with me, Declan Cheller.
This tutorial is aimed at people who are new to process modeling and experienced process modelers who want to take a more structured approach. But first, some symbols. Instructions are indicated by this graphic, handy tips by this one, warnings by this one, quotes from the BPMN 2.0 specification by this one, and pop quiz questions by this one.
This video is a short introduction to the meaning of the gateway shapes, but it's not an exhaustive tutorial on how to use them. Gateway Basics. Gateways are used to control how sequence flows interact as they converge and diverge within a process. We use a gateway shape to navigate the model when alternative or multiple paths are possible. No work is done within a gateway. It's nothing more than a visual navigation device for your model. So gateways are instantaneous, and you cannot assign them to a role nor associate them with costs and KPIs. In this example, the previous subprocess has more than one possible outcome. The subsequent gateway allows us to navigate the process according to the actual outcome. The data to be consumed by a gateway must be available in the process before it reaches the gateway. Here, the data is the outcome of the previous subprocess. In this example, the data is the outcome of a business rule task. The logic of the business decision is documented within that task. In this example, the data was entered by a human in a user task. In this example, the data was received in a message. And in this example, the data was retrieved from a data store. Note that the data consumed by a gateway may have entered the process much earlier. The sequence flows that follow a gateway are called gates. If the gates are labelled yes and no, you must label the gateway itself to make the question clear. Otherwise, labelling the gateway is optional, and I do not usually label it if the context is clear. With exclusive and inclusive gateways, label the gates coming out of the gateway to cover all allowed outcomes. Otherwise, the process will not be able to proceed beyond the gateway for an unanticipated outcome. If this oversight found its way into the software design, it would lead to runtime errors. What, if anything, is wrong with this diagram? Pause the video if you need to think about it. The gates coming out of the exclusive gateway must be labelled. What, if anything, is wrong with this diagram? Pause the video if you need to think about it. The exclusive gateway must be labelled with a question to which yes and no are the only allowed answers. Diverging and merging. A gateway that has one incoming sequence flow is called a diverging gateway because it splits the flow. A gateway that has one outgoing sequence flow is called a merging gateway because it merges flows. A gateway must be either diverging or merging. It cannot have only one incoming and one outgoing flow. A gateway must be either diverging or merging. It cannot be both at the same time. Exclusive gateway. A diverging exclusive gateway is used to create alternative paths within a process flow. This is basically the diversion point in the road for a process. For a given instance of the process, only one of the paths can be taken. Although the BPMN specification refers to gateways as decisions, I feel this is misleading. At a basic level, the process is asking itself, given this datum, which way do I go now? But it's only ever a single datum, and it does not require the sophisticated logic of an actual decision model. So I recommend you think of the business rule task as a decision, and the gateway as merely a navigation signpost. A diverging exclusive gateway like this means that the process can follow only one of the subsequent gates. An exclusive gateway can be represented with or without an X within the diamond shape. Each gate must be labeled with the condition that allows the process to flow through that gate. Where you do not know all possible conditions at the time of designing the model, document the ones you do know and use the default sequence flow to stand for otherwise. Using the default sequence flow will ensure you do not have any runtime errors for unknown conditions. You do not label default sequence flows, since they have only one meaning, which is otherwise. Use a merging exclusive gateway if you want to merge flows that were split by a diverging exclusive gateway. You can merge flows by sending them to the same activity or event, but I prefer to use a merging gateway. If you do not merge split flows, each one must ultimately lead to a separate end event. This model says that on Mondays in June, we perform task B, but on any other day in any other month, we perform task C instead. It's perfectly legal to model this way, but it's untidy. Moreover, by exposing business rules like this, you will have to change your process model if the rules change. So don't use sequential gateways to model complex decision logic. What if the rules later change to Tuesdays in July? What if we later have to add a third condition? Instead, handle the conditions and rules inside a decision model. And put that decision model behind a business rules task. That way, your process model will not change even if you later need to change the logic of the decision model. What, if anything, is wrong with this diagram? Pause the video if you need to think about it. The outgoing gates do not cater for every possibility. This model would lead to a runtime error for a customer credit score of 50 to 59%. You can correct this by having a third gate, either to explicitly cover the missing range or to indicate otherwise. What, if anything, is wrong with this diagram? Pause the video if you need to think about it. This is perfectly fine. Since apple and cherry are mutually exclusive, the end event can only be triggered once. Inclusive gateway. A diverging inclusive gateway can be used to create alternative but also parallel paths within a process flow. Unlike the exclusive gateway, all condition expressions are evaluated. The true evaluation of one condition expression does not exclude the evaluation of other condition expressions. A diverging inclusive gateway like this means that the process must follow any of the subsequent gates where the condition is true. In this example, we may have apples, or we may have cherries, or both, or neither, or we could have both and other fruit types. A merging inclusive gateway is special in that it waits only for those sequence flows that were activated by its diverging counterpart. In this example, let's assume we have only apples and cherries. The merging gateway waits only for the highlighted flows to complete before proceeding to the task Close Kitchen. A diverging inclusive gateway must have a merging counterpart. In this example, without the merging gateway, the task Close Kitchen will be triggered twice if we have both apples and cherries. In this example, the merging gateway means the task Close Kitchen will only ever be triggered once. What, if anything, is wrong with this diagram? Pause the video if you need to think about it. This is perfectly fine. However, the model only caters for apples and cherries, so it will have to be updated if the business introduces other fruit types in the future. Parallel gateway. A parallel gateway is used to synchronize parallel flows and to create parallel flows. A diverging parallel gateway like this means that the process must always follow all the subsequent gates. You never label a parallel gateway because it has only one meaning: follow all the subsequent gates. All outgoing sequence flows are activated immediately and concurrently. The tasks immediately following the parallel gateway may be performed in any order or at the same time if feasible. You must merge flows that were split by a diverging parallel gateway. The process will not proceed past the merging gateway until all incoming sequence flows have completed. What, if anything, is wrong with this diagram? Pause the video if you need to think about it. A diverging parallel gateway must have a merging counterpart. In this example, without the merging gateway, the task Get Dressed will always be triggered 3 times. The merging gateway ensures that the task Get Dressed is only triggered once and only after all the previous tasks have been completed. Event-based gateway. The event-based gateway represents a branching point in the process where the alternative paths that follow the gateway are based on events that occur. An event-based gateway means that the process follows only the subsequent gate where the attached event occurs first. An event-based gateway is always exclusive and diverging. You never label an event-based gateway because it has only one meaning. Follow the flow of whichever event occurs first. In this example, if customer confirmation is received within 24 hours, the process performs the task Save Customer Confirmation. However, if 24 hours pass before receiving customer confirmation, the process proceeds to the end event Cancelled. If customer confirmation is received after 24 hours, the process will ignore it. We can also use this pattern to resend the request for customer confirmation. In this example, the process doesn't end after 24 hours, rather it sends the request every 24 hours until the customer confirmation is received. In this example, we'll limit the number of times we request customer confirmation to a maximum of 3. According to this model, in what order do we expect the events following the event-based gateway to occur? Pause the video if you need to think about it. It's a trick question. Event-based gateways do not impose order on subsequent events. Rather, at runtime, the process will follow only the path of the first event that occurs after the event-based gateway. Complex gateway. The complex gateway can be used to model complex synchronization behavior. You use a complex gateway when none of the other types of gateway can express the desired synchronization behavior. In 11 years of using BPMN to model complex business processes, I've never needed to use the complex gateway. So, I don't have any examples to offer from my experience. This discriminator pattern is based on an example from Bruce Silver's book, BPMN Method and Style, which I recommend. Here, task D always occurs, but only once, and after whichever completes first of task B and task C. Although both task B and task C must complete, task D only needs one of them to complete before it can start. Since the complex gateway has no specific meaning, the logic of the synchronization must be stated in an annotation. There is no other way to express it. What's next? In my next video, I shall cover message flows.
Watch out for my other tutorials on such topics as structured approach to building a process model, when to model decision logic instead of process logic, introduction to modeling business concepts. If you found this tutorial useful, please click like and subscribe to my channel for more. Thank you.